Hi, welcome to this video. This is lesson number 7 in the Polynomials chapter at Higher. And today we're going to be finding the equation of a polynomial from a graph. Now you should have seen this at National 5 for finding the equation of a quadratic, but we're going to take it up a notch and find it for anything with a degree of 3 and above. Okay, so what we have here is we have a quadratic graph, and we know it's got roots at -5 and 2, and we're told one other coordinate on the picture, which is 1, -12. And if you know those two roots and at any other point you have enough to get the equation. So what we're going to look at is this general form here. So the general equation of any quadratic polynomial and so on is this, and the number of brackets corresponds with the number of roots. So when we go into a cubic function, there may be 3 roots, so we'll add on an extra bracket, which is x minus c. And what we have is basically the roots of the numbers in the brackets. Because remember, when you solve a quadratic and you factorise it and you break up the brackets, that's how you're finding the roots. So in this case, we're sticking the roots back in. So this is like a quadratic shape, and it's got roots at -5 and 2. So we're going to sub them into the equation. So we end up with y equals k, -5 turns into +5, and 2 turns into -2 when you sub them in. So that's what we've got. Now the other bit of information we've been given is this coordinate. And I like to try and drum it into my pupils. Whenever you have a random coordinate, it gives you a value of x and y which you can substitute in. So I'm going to replace y with -12, and I'm going to replace x with the number 1. And you would then get -12 equals k bracket 6 bracket -1. So we have -12 equals -6k. So k is obviously the number of +2. So to finish the question, the general equation, or the equation of this graph, would be k is 2, and we said our roots were, or our brackets were that. So this is the final answer. This is a graph of 2 bracket x plus 5 bracket x minus 2. Okay, so what we have now, this is a graph of a cubic, and it's got 3 roots. So that's why we have x to the power 3. We have x cubed at the start, so it's called a cubic shape. And we've got roots at -6, -3 and 1. So they're the numbers we're going to plug into the brackets, okay? So we have y equals k bracket, that will turn into a +6, a +3, and it'll be x minus 1. Now the other bit of information you've been given is this coordinate here. You've been told 0, -36 is your random coordinate. So that's the values we're going to put in for x and y. So we have -36 equals k bracket. Now if I'm just putting in 0, I'm not going to bother writing that in. I'm just going to go straight to this bit. So -36 equals -18k. And -36 divided by -18 is 2. Now k doesn't always happen to be 2. That just happens to be what I've chosen it to be for these two examples. So now we have k equals 2. We can rewrite out our equation. So we have 2 bracket x plus 6, x plus 3, and x minus 1. Okay, so there is your final answer. We have found the equation of that cubic graph. Now one more to show you. This is a cubic again, just because the shape looks a bit like the last one, but notice this one only has 2 roots. Now this bit here is important. We have a root at x equals 3. And we say that is a repeated root because it touches the x-axis. If you cast your mind back to National 5 when we were talking about the discriminant and the nature of the roots, we said if b squared minus 4ac equaled 0, then we said it had 1 repeated real root. And that's what's happening here. This is our repeated root. So what we do is when we plug this in, we plug in the 3 twice. So repeated root means it's only touching the x-axis. Whether it's a quadratic or a cubic, it's the same thing. So when we put this into the general form, we have y equals k, -2 becomes +2, and then that 3 would become x minus 3, and I'm just going to write it out twice. So if it's touching, it's repeated, okay? Because a cubic should have 3 brackets, and we need a third bracket. Right, we have a coordinate here. That's going to be your x and y values. So -36 equals k bracket 1 add 2, 1 minus 3, and 1 minus 3. So that will give us 3 times negative 2 times negative 2, which gives us 12, positive 12k. 36 divided by 12 is negative 3. So k is negative 3 in this case. So our final equation will be y equals negative 3 bracket x plus 2 and x minus 3. Now you can write that bracket twice, or you might see it sometimes with a squared at the end. So it's up to you how you want to write that at the end. I've put the squared in because I honestly didn't have enough room to put in that extra bracket. So that's me showing you 3 examples. This is a really important one because it's got that repeated root, and that will come up a couple of times at higher. Okay, so if you have access to the TJ textbook, this is the page and the questions I would recommend trying. Go to page 116, question 3. I've pulled out a wee selection. I definitely like F, I think, because it's one with a repeated root. There might be others in there. I have missed out a couple. Feel free, you can do them all. There are a couple of weird shapes that maybe look like this, where you have 4 roots, and it would just be the exact same process, even though I haven't done one with 4 roots, but it's just the exact same. You'd have 4 brackets on that one. So thank you, good luck.